this is my view of the art and science of rust pathology and applied plant breeding. Sorry. And you may recall that Dr. Joshi said it's not complicated, it's rather simple. That's not my view. Okay? If we all think alike, we only need one of us. So the conversation we've been having, this is wonderful discussion. So I think it is, in fact, not so simple. This is my view of the disciplines of an integrated approach to plant breeding. And there are many different disciplines, and I've listed them here. We're familiar with this discipline of plant pathology and statistics and genetics and molecular biology, but now we've got a lot of information to manage, so we need to know something about computer science, and at the end of the day, our job is to deliver a variety to a farmer or to a customer. We have to work with other people. This is human resource management. Mechanization is increasingly important with lab robotics and field equipment. My goodness, the stuff that is being designed these days. Grain science, milling quality, baking quality, nutrition, nitrogen, iron deficiency, and on and on. Animal nutrition, we have to remember that as the world gets wealthier, more animal protein is consumed, and so that energy source comes from plants. Agronomy, field management, crop production, soil science. I have said many times that good research really begins with good agronomy, and if we can't do that in the field, we have a problem to start. So, at this workshop, we're going to concentrate on plant pathology, of course. We're going to talk about genetics. Genetics of both the host and the pathogen. And molecular markers that have an influence on what's transmitted and how to use them and the problems that are associated with molecular markers. We're going to talk about varieties and releasing varieties and all of the information that can be used from surveillance, from molecular markers, from a grain science evaluation of quality, all of these things that go into releasing a variety of wheat to a customer who is always right. Some of you have heard me say that rule number one is the customer is always right. Dr. Prasher has heard me tell this many times. Rule number one, the customer is always right. Rule number two, when the customer is wrong, see rule number one. Okay? Because he's the one, or he or she is the person who is going to use your variety or not. And the other thing that we have to do, I think, is the science of statistics applied to the world of biology. And this is something that helps us to understand all of this variation, the heritable part of it and the not so heritable part of it. And so we've got Neil McLaren here who is going to give us some lectures and allow us to ask more questions again and to begin to understand better how the science of statistics applied to biology and crop improvement is important in what we do. So again, my view really is it is rather complicated, and it's not possible to be an expert in all of these things. If you're a pathologist, you know pathologists very well, and maybe not genetics quite as well. If you're a geneticist, you know genetics better than you know pathology, and there are the rare exceptions of us, like Joshi, who knows all of them, both of them well, okay? But there are so many disciplines to be familiar with, and the sciences continue to make progress. And we have to be able to use those and integrate them into our program. We have to know people who know something about them so that we can communicate with them. So it is important to work collaboratively and develop the complex solutions, the complex integration of all those components into a progressive plant breeding program. So this is, I've relied on this article a little bit. It's from a paper in Crop Science in 2011. Skill requirements from public, critical knowledge, experience, and skill requirements from public and private stakeholders. This is what people think is important if you're interested in a career and in a job that is involved with plant breeding. So I don't think you can read that very well, but that's a plant breeding education. There, I told you that already. Sorry. So this is now the project description that was offered in the publication. So the occupation of plant breeder has changed substantially over the past 2 decades. A well-trained plant breeder should be one who can work at the interface of dynamic, multidisciplinary teams. Plant breeders should have core competencies in breeding, genetics, a strong background in statistics, molecular biology, and etc. It is important for breeders to be able to communicate with colleagues in these teams. So again, this is just a little easier for you to read. These are the core competencies. And breeding involves the simple suggestion that Dr. Joshi made. It is all about generating new variation that is desirable and then selecting on that variation. Agronomy, of course, is fieldwork. Statistics and experimental design is important in what we do. Data management, computers, molecular biology, end-use quality, and serial chemistry. Those are the core competencies that this particular publication thought were most critical. But you also have to be able to collaborate and understand some of the basic principles of some of these other sciences. And this is not an exhaustive list, but computer programming, engineering, genetic resources, all of these things that go into those other components of an integrated system of applied plant breeding in utilizing all the scientific progress that is being made in today's world. So this is my view of the art of plant breeding. So you have to take and marry the knowledge of these core and associated competencies with experiences in the field, in the laboratory, in the office, that are related to plant breeding and that result in successes, we hope. But I don't know of anyone who has released a variety and not had it become very popular. We're not always right when we release a variety, my experience. When we release a variety in the U.S., the marketplace tells us whether we did a good job or not. A customer comes back again and buys some more, or he or she does not. So I think we learn from our failures. Humans make mistakes. If you make too many, you don't get to contribute to the next gene pool, I guess. Natural selection, maybe. So we've alluded to the importance of statistics, and in previous workshops we had not focused very intently at all on the statistical sciences applied to the world of biology, which is what Neil calls biometry. And these are some of the reasons why they are important, and we'll let Neil tell us the rest of the story in the 5 lectures that he's going to give to us. So for your reference, this particular article will be in the flash drive that is given to you, and if you're interested in it, there's some information in there that I think you'll find pretty interesting.